without further ado, let's get the real show started. We have Scott, who is going to give us an incredible talk about Apple's new Endpoint security framework and some really interesting research he has done.
So last year, WWDC, one of the most exciting things announced, I think in my opinion, was system extensions. So in this talk, I'm going to kind of go over one specific type of system extension, an endpoint security system extension. I'm going to go into details on the internals of the framework, kind of how it works, how Apple architected it from a reverse engineer's perspective. And then I'll get into a vulnerability in the framework that I found and reported to Apple. Real quick, who am I? Like Patrick said, Scott Knight. I'm a threat researcher on the threat analysis unit at VMware Carbon Black. I like to describe myself as a Mac OS enthusiast, especially Mac OS system internals. And you can find me on the web, GitHub, Twitter, the usual places. So I'm going to start and kind of just give a kind of broad overview of system extensions in general, because I think it's important to kind of set the stage of what they are, and then I'll go into the endpoint security one specifically. Then finally, like I mentioned, going into the vulnerability and kind of what my thought process was and how I went about finding it. So what are system extensions? Kind of boiled down, they're essentially user space kernel extensions, sort of. There's definitely limitations. You have to package them inside of an application, which can be a little funky because traditionally kernel extensions are installed at the system level. There's currently 3 different types. There are driver kit system extensions, network extensions, and then the endpoint security extensions. And Apple's sort of overview page actually does a pretty good job of just sort of giving that broad overview of those 3 different types. So why would you want to use a system extension, either as a user or a developer? Apple made it pretty clear last year that macOS 10.15 will be the last release to fully support kernel extensions without compromise. So I don't think it should come as a surprise to developers, for sure. But yeah, Apple does not want developers in the kernel. More than that, though, I think it presents a lot of exciting opportunities from the development side. The promise of being able to use more programming languages than just C and C++. Nothing against C and C++, but anybody who's been doing other macOS development using Objective-C or Swift, it's a lot nicer than having to just write low-level C code. And theoretically, it should be easier to debug because you don't have to set up a complicated kernel debug setup where you're trying to debug your driver or you're trying to take crash stack traces and symbolicate them and track back why the thing crashed. I thought it would be useful just to kind of cover briefly how Apple has kind of changed and locked down things over time with kernel extensions. And again, I kind of just said that it shouldn't be a surprise that Apple does not want developers in the kernel. So in 10.9, that was the first version of macOS where Apple said, okay, you should be signing your kernel extensions. We don't want just anything running in the kernel. 10.10, then they kind of went a step further and said, okay, it's not a should, it's a must. You have to sign your kernel extensions. But there is a boot argument. You can set it, you can disable it if you want. 10.11, then it was just, no, it's required. They removed the boot flag and pretty much kernel extensions had to be signed. 10.12, there wasn't really huge changes. 10.13 was quite interesting because that introduced kind of user-approved kernel extension loading. So again, Apple's just kind of continuing to lock things down. They said it's not good enough that we've got a kernel extension that's theoretically been signed by a developer that's been vetted by us. We want the end user to actually have to click a button and approve the kernel extension loading. And more than that, they went to great lengths to make sure that it has to be a real user sitting there. You can't script it away. You can't try to programmatically load it and get it to click and disappear. 10.14.5 then they started to introduce the concept of notarization, which sort of is another level of vetting by Apple in a way. In addition to signing your kernel extension, you submit your code to Apple. They run some automatic sort of sanity checks to make sure you're not doing evil, and they stamp it notarized. I don't think they said, but essentially it's just a better way for them to be able to control and revoke things that I think they think shouldn't be out there running. 10.15 then said, yes, everything should be signed and notarized, and then the big announcement with 10.15 was system extensions, and them saying that long-term, they were 100% planning to deprecate kernel extensions. So there's been a lot of speculation, 10.16, kind of based on looking at this history. I don't think you're going to see everything banned come 10.16. I think you'll see the sort of slow progression of more warnings. Apple they've already started in certain versions to kind of prompt the end user, let them know, hey, you're loading a kernel extension, it's going to be deprecated, start talking to the developers of these things. So system extensions in general, kind of what does it look like? It's very complex, all the different moving parts in the system. And you'll hear me kind of come back to this topic. But you've got everything from the user application that you have to get installed that contains your system extension, that then has to kind of go about the steps to get it installed correctly. It's coordinating with a new system daemon called System Extension D, which then delegates out to other daemons, which then delegates out to launch D, which then finally runs your system extension. Your system extension is going to run pretty much like a system daemon. It's going to run as root. And then those system extensions are what talk to the kernel. And the kernel then is kind of Apple's playground. They're trying to kind of say, it's off limits, we're going to write all the APIs you need. Here's everything that you need. So I'll touch on the system extensions that are not endpoint security just briefly, like I said. Driver kit is an interesting one. If anyone has ever looked at writing Apple drivers, they have a framework called IOKit. It's pretty robust. It's C++. It's got a whole inheritance structure. You can write your USB drivers and inherit from common Apple USB code, so you're not trying to write everything from scratch in your driver. Driver kit is kind of, their move to kind of put this into user space, and it is very similar to IOKit. Currently, it supports USB drivers, serial drivers, network drivers, and kind of human interface devices. It's still C++. Thumbs down on that, because you kind of lose out on the promises of, well, I can write these things in Swift or Objective-C and all that. So I'm hoping maybe that evolves a little bit more. But it kind of comes from the architecture of it all, which is pretty interesting. Apple kind of set up this whole user space, almost mirror of the kernel space IOKit. And when you run a driver kit system extension, it's actually going to go and register with the kernel and create the similar sort of classes in the kernel space that it did before, where normally you'd create them. Now it just sort of mirrors them in the kernel and forwards things back and forth between them. So Apple did just release kernel source code, so it's been interesting to kind of poke around and see a little bit more about how they went and implemented some of the driver kit stuff. Network extensions. These I didn't dig into a whole lot. Some of these existed prior to Catalina. Some of these existed already on iOS. But if you were writing, say, a firewall before, you were using network kernel extensions. Now, again, you're doing kind of a user space application. You can implement custom VPN protocols. You can do your sort of traditional firewall stuff, filtering flows or filtering individual packets. And then it also supports DNS proxy type things. And this was one of the areas that Apple actually did release an example app, and you can write this stuff in Swift, and it is pretty cool to kind of see that where something before you were writing in kernel space, you were using C, C++, and now you can kind of more easily kind of use these things and debug these things. So endpoint security. Here's our kind of architecture diagram again, kind of cut down, showing all the main pieces that are used as part of the endpoint security architecture. Again, you've kind of got user space, talking to multiple system daemons, eventually your own system extension is running, and then talking to an Apple kernel extension. I'm going to go over kind of the details of each one of these pieces and start actually from the bottom up. So I'm going to start with the kernel because that's definitely the place where Apple provides the least public information about kind of what they're doing, and it was what originally prompted me to kind of dig into this new framework to kind of see what were they doing, how did they architect it, what were they trying to provide to us as developers. So endpoint security kernel extension, you can find it in system library extensions. If you've never looked at a kernel extension, it is just another bundle, just like an app bundle. So you can open it up, you can inspect it. It has an info.p list. There's kind of a snippet here of just some of the stuff in the info.p list. Since this is an IOK driver running in kernel space, you don't have your traditional main entry point. So instead, in the info.p list, you'll have different classes called out related to telling IOKit how it should load the driver or run the driver. So this is usually when I'm looking at a kernel extension that I don't have source forward and reverse in it. I'll start there, try to look at some of these main classes identified here, and then go forward. Because it is C++, you do get some nice runtime information to start pulling out class names, methods, things like that. So there's really 4 main classes to this driver. There's the endpoint security driver, which is mentioned in the info.p list. This is kind of the entry point of the kernel extension. There's an endpoint security event manager class. This really is taking care of doing all of the hooking in kernel space, basically using Apple's public and non-public APIs to kind of pay attention to everything that's going on in the kernel to provide that information then to your system extension. There's an endpoint security client manager class. It's just strictly keeping track of different clients that are connected. Clients in this case would be the system extension that you've written as a developer. And then there's an endpoint security message manager, which is doing the communication. So this is really after the hooks have been set and it's forwarding messages back and forth, this is the class that's responsible. And Apple does a good job just trying to be efficient here. I think sometimes when I think of security kernel extensions, there's a lot going on. Apple tries to keep it pretty minimal and make sure that they're only hooking things when they need to. So if you've got a stock Catalina machine, you've never installed any system extension, this kernel extension really isn't doing much. It's not hooking anything, it's not forwarding any events anywhere. It's really not until you have a system extension that's installed and running that then it will sort of activate the hooks that it has and go from there. So in terms of what this kernel extension is doing, there's really 2 sets of APIs that drive kind of its hooking functionality. The first is a kauth listener. This is a public Apple kernel API that's been in the kernel for a long time. I would say that it's never really been used in great detail by actual products because it's not very robust. There's limitations to kind of what it can do. In the case of endpoint security, again, reverse engineering, I'll usually start with kind of what are those public APIs and start searching for that stuff. So in this case, you can search for kauth listen scope and start to see what is the kernel extension doing. You can see that it's registering and it's listening for file operations, file up, and it's saying when this file operation triggers, here's this method to go and run. If you then go and kind of look into that method and see what is it doing, there's really only one case that it handles, and that is file op close. So this is kind of interesting. This is one of the APIs that, again, is public. Apple has said is deprecated. So as a developer, when they announced system extensions, they said this is deprecated, don't use this anymore. But they're using it themselves within the kernel extension, but really just for this small case of handling when files close. And it's kind of interesting. My best guess is just that the timing of where this hooks into in the kernel, they felt like we still want to use this API to get this one tiny hook point to be able to notify system extensions. The other larger sort of kernel APIs that are being used that are actually not public, but everybody uses them, is the MACF APIs, Mandatory Access Control Framework. If you've ever looked at any other security kernel extension, it is definitely using this. Lots of Apple extensions use this. It's how they build up the security of their operating system. So again, we can kind of start from that API that is known when you're kind of reversing this stuff. In this case, it's Mac policy register. And we can start to see, okay, what are the parameters that are passed in to this function call? And even though it's not public, it is a method that is pretty well documented on the internet, and you can look into kind of the internals, but in the kernel source code. So the first parameter there is this sort of big mega structure that specifies all this information. If we sort of start to decompile that structure down, we can see that they're defining an endpoint security kernel extension. There's some label names, but the most important thing are these MAC operations. This is basically a giant array of every single hook point that you can sort of point your function to and say, okay, when this fires, here's my function that I want you to run. So we can start to look at what is Apple's kernel extension hooking within really this main area that they're hooking stuff. There's really four main hook categories. There's file events, process events, socket events, and then a couple of kernel events. I don't think anything too surprising in terms of when I looked at this and reversed into this. It's what I would expect for Apple trying to provide a public API essentially for security vendors to make endpoint security applications, endpoint security system extensions. They do all have names that start with ES underscore, so even without necessarily going to the kernel source code to see what are all the values in this giant array of operations, you can at least look at the names and start to see what are the different things they're hooking. So things like ES file check dupe, it's hooking a point in the dupe system call where it's going to call into this. The kernel extension does have user space communication. This is an area where I think IO-Kit drivers tend to be robust, but also really nice for reverse engineer because they provide these nice sort of C++ APIs that are kind of easier to get at versus if you ever think of looking at maybe a driver on Linux and you're trying to reverse engineer it and you're looking at like a IO control call and trying to figure out what was this number, what did it mean, that sort of stuff. So IO-Kit has an IO user client class. What you'll see in drivers is that you'll have a subclass of that created, and then that's kind of when a user space application wants to talk to the kernel extension, they're kind of communicating through that interface. In this case, there was actually two subclasses of IO user client in the driver, which was kind of interesting. One was a class called Endpoint Security Driver Client. This one requires entitlement, COM Apple Private Endpoint Security Manager, and there's only, at least when I checked, I think the original release of Catalina, only one binary on the system that has this entitlement, and that's Endpoint Security. The second user client class is Endpoint Security External Client. It still does require an entitlement. In this case, it's COM Apple Developer Endpoint Security Client. This is the entitlement that if you're a developer and you want to write an endpoint security system extension, that you're essentially applying to Apple for this entitlement that has to be granted. And your system extension then is the one that has this, so it can connect and communicate. But again, the nice thing about having these two class names is now we can kind of just start grepping through some of the disassembly, not even necessarily getting into the functions themselves, but just trying to look at what are these classes, what are the method names that come with them, and get a better idea of, okay, what type of API and communication do we see going on. In the case of the driver client, so this is the privileged API from Apple's binary, there's only two methods. There's one called clear cache and another called register for early boot. So Endpoint Security D doesn't do a ton of talking to the kernel extension, which honestly, when I kind of started looking into this whole architecture, kind of surprised me. I assumed based on how Apple typically architects things, well, sure, they've got their kernel extension, they've got a system daemon, kind of the same name. That's what's talking to each other. They're doing a whole lot. In this case, not so much. Endpoint Security D is kind of involved in some of the early boot stuff, and we'll see later on kind of what its actual purpose is. So the main APIs really come from the public, if you will, aspect of the driver. And when I say public, it's still restricted by entitlement. But we can see that there's basically methods for kind of subscribing to something, unsubscribing from everything, muting different processes. So this is clearly the class that is corresponding with what your system extension will do. So moving up this sort of stack, out of kernel space now, the next thing we get to after the kernel extension is really your system extension itself. This is really what is doing the communication with the kernel extension. And there's a new library called libendpointsecurity.lib. It is a C library that you use in your system extension, which presents some challenges at times because it's not very high level. And this is what's actually using the IOKit user space calls to then communicate with the kernel driver. If you've ever done anything with IOKit or maybe looked at malicious applications that are trying to get platform serial numbers or things like that, you'll see IO service matching calls. They're trying to connect to the driver and then call those methods that we just looked at. Right now, this library it appears to be just like a very thin wrapper around the IOKit communication. My hope is that this is one of those libraries that Apple will continue to update and improve and add kind of like higher level abstractions onto it. It is possible to call into this library from Swift without using bridging. It's not awesome calling C code from Swift, right? If we go up kind of one more level, then we'll get to Endpoint Security. And again, I mentioned this was what I originally thought was going to be doing most of the communication with the kernel driver, which was not the case. I originally was anticipating that your system extension would talk to this daemon and this daemon talk to the kernel. In this case, Endpoint Security D is really there just to validate the endpoint security system extensions, as well as then communicating via, it itself has appropriate entitlements to communicate with launchd to then run your system extension as a root daemon on the system. And then it is involved in early boot startup of endpoint security system extensions. You can set a flag in your info p list and essentially say, my endpoint security extension is so important that I need it to load earlier on in the boot cycle. Going up again, we get to the system extension daemon. This daemon is interesting. It's got a lot of code for a new daemon. Right now, for the most part, all that code is being used to kind of validate and activate system extensions. So it moves things into the proper locations and then really just asks Endpoint Security D to do the real work of loading this thing. If you remember back to kind of the first diagram I had where it kind of split out into three pieces, if you have a network extension or a driver kit extension, system extension D is trying to figure out what type of extension it is, who do I need to really ask to do the real work, and then going on from there. Once we get up to the user level, then there is an actual framework that Apple has provided, System Extensions Framework. Again, when I first glanced at this framework after they announced it, this was another spot that I thought, oh, there's going to be all this interesting stuff in this framework. Here's where I want to start. It's not a lot here. It's really just activate a system extension. There are different sort of internal classes within this that Apple leverages in some of their binaries, but for the most part, this is just how your installed user application can tell the system, I have a system extension inside, go ahead and activate it. There's one more binary just worth mentioning in user space, and that is system extension control. Does not have great documentation, which conference full of Mac people, I don't think would be surprising. Apple's not always awesome at documenting brand new things. So if you do a man page on system extension control, it just says this controls system extensions or something like that. So, but essentially it provides very basic control to the system extension daemon. On the right here is kind of just a list of methods from the system extension daemon, where if you're looking for the commands that it understands, these kind of correspond to with what system extension control can do. It's basic stuff like list the extensions that are installed, check the extension, uninstall the extension, handful of methods named testing, which in the betas you could actually trigger some of these test methods through system extension control. It seemed to be just, I think, a way that internal Apple QA was working to kind of test the process and the orchestration of all this stuff. You can give it help on the command line, and it gives you a little bit more information. You can see some of these same commands, a list, a reset, and uninstall. If you're building a system extension, this binary is important. You can basically turn on a developer mode, which just relaxes some of the restrictions that the system has on system extensions and when they're allowed to run, who can run them. So that is kind of top to bottom of all these different parts. And here's kind of the image of it again. Again, a lot of moving parts. A couple of things that I just want to call out that struck me as I started playing around with this whole framework, after WWDC, is that because of all these moving parts, it was real easy to get into weird situations where you thought you had a system extension, you said go ahead and activate it and run it. System extension D may have said, perfect, this is valid, go ahead and activate, pass off endpoint security D, and then endpoint security D we find something wrong and say, nope, this can't run. And you don't get any feedback, you just have this API that kind of returns right away, and you're hunting through the console trying to figure out what went wrong. The other common thing is just that I think a lot of the folks who were looking into this API originally were interested in just creating command line tools to kind of play around with it. They didn't want to create a full user app and things like that. And because you're required to have this entitlement, it can be kind of tricky at times with entitlement validation. Sometimes entitlement validation in the system is looking within inside a bundle. So even though you can add entitlements to a command line program, it's not always easy to create this thing, get it signed, notarize the correct entitlements so that it's working in the command line. So onto this vulnerability, CVE 2019-8805. Apple described it as just a validation issue that existed in entitlement verification. So I'm going to go into kind of how I went about finding it, kind of my process, some of the stuff that I reversed for that. With any reversing, again, I kind of start from the APIs. So looking at what's known, what's public as a point to kind of start digging into this stuff. In this case, here's a couple snippets from the system extension framework documentation. So again, you have kind of an activation request and then submitting that request to the system to try to activate your system extension. So in the system extension framework, there's a couple different classes that are interesting. There's this OS system extension manager. I think that's the one you're actually using in your user application that Apple does have some documentation on. Behind the scenes, though, that's actually creating the OS system extension request object, and then there's appropriate subclasses of whether it's an activation request or a deactivation request. But essentially, that framework is just creating some of these details around what your endpoint security system extension is and passing it off to the system extension daemon over XPC. So real quick, if you've never seen XPC, it is an inter-process communication protocol. So think, being able to call methods in another process from your process. It's pretty nice compared to, let's say, if you're trying to use the low-level mock message APIs. You can define a protocol where you can just say, hey, conceptually, in this case, for Apple's documentation, it's a method called feed me a cookie. You can define it, and then your server kind of registers and says, hey, I'm listening on XPC. Here's my protocol. Here's the methods that I provide that you can call. And the clients just then have to kind of connect to it and can just start calling those methods and passing across information. This is, basically what the system extension framework is doing as it's trying to talk to the daemon itself. And it's a very common pattern across Apple and all their system daemons at this point. So again, kind of from looking into internals, looking at kind of the security of these new system daemons, it's a place that I'll usually start just to kind of see, great, Apple has a public API, but then one level down, what is it actually doing with XPC? What is it sending off to the system daemons? And are there any maybe things not documented as part of the public API that I can see within these XPC protocols that are being used? So within the system extension daemon, we have a main class called sysextd server. This is kind of your main listener class. And then this is kind of boiled down to just a handful of classes, but it'll listen to the kind of the requests coming in from the framework, getting passed in. You can see kind of the system extension API framework client class, which then is calling into a standard extension delegate class. So one of the things that struck me, and I think I mentioned earlier about the system extension D, is that there's a lot of code in it for a new daemon compared to at least what I was able to tell from reversing that it did. I think it comes from the complexity of this daemon having to handle all the different system extension types, as well as I think Apple planning for there to be more system extension types in the future. So standard extension delegate, that name standard there, they've definitely built up this whole sort of object hierarchy of different internal classes, so that in the future there could be more daemons like Endpoint Security D that are handling different system extension points. So I kind of started here with these first two pieces, the system extension framework, system extension D, and XPC. At this point, you can use something like class dump. You can run it on system extension D, and you can get that protocol that it's using out to kind of see, again, what does it support? And you can basically build a little stub application. Rather than going through the system extension framework, take your little stub application, copy and paste your class dumped protocol out, and then just use kind of standard XPC methods to then connect to this service and run different methods. And in this case, you're starting from the system extension framework, which is meant to be called from user space. It's probably the least amount of security restrictions because a normal application is meant to call these things to activate a system extension. And I just sort of started manually fuzzing this, if you will. I wouldn't even call it fuzzing, I'd call it maybe just doing QA. Kind of just trying to call these things, what are the different things that I can pass in, what are acceptable values. Again, system extension D really only understands kind of an activate, a deactivate, but passing in different things and watching the console and trying to figure out what's happening internally, cross-referencing with disassembly. The new, the log framework is pretty robust. Console is a great place to look at that, and you can usually find those log messages in a disassembly to kind of correlate these things and pay attention to what's happening. Ultimately, this didn't lead me anywhere. There's not a lot that is happening. System extension D did a pretty good job of trying to validate these things and then pass them forward to the next piece. So again, just kept going down the path to understand, like, okay, what happens when it passes off to the next level. Again, it's XPC communication again. In the case of Endpoint Security D, again, you have a main class called ESD. It is doing the kind of the XPC dance of starting up and declaring itself as a listener and saying, these are the methods and here's the protocol that I support. Endpoint Security D is interesting though, because it is using SM job submit. And again, this is the piece that's talking to LaunchD. So as a regular application running as a regular user on a system, you can't tell LaunchD to run something. But Endpoint Security D does have the proper entitlements and permissions to do that. So again, kind of continuing through this process again, okay, doing class dump, pulling out these methods, and starting to play around with them. In this case, it was a class that actually exists in the system extension framework, a private one. Again, I mentioned kind of the clear thought from Apple of kind of building out this, I don't know if I want to say overly complex, but sort of forward-thinking way to support more system extension types in the future. So a lot of the common functionality you may find in private classes in the system extension framework that then get used by the private daemons that Apple's creating. In this case, at first, there's not really any methods that are maybe that different from an activate or deactivate. You see one level up in system extension D. You have start extension, terminate extension, validate extension. But I think this was kind of the first place after having kind of pulled out the flow of everything and looking at some of the stuff that I thought, maybe this is a good spot to kind of focus a little more time on. Just looking at some of these, you kind of can tell, based on having start extension and will start extension, that there's sort of this flow of events that are supposed to happen that are being coordinated by the system extension daemon and then passed to Endpoint Security D. So I could sort of conceivably, even without getting into all the details, just from the names start to understand system extension D is maybe doing its level of checking, but then handing off to Endpoint Security D and saying, validate an extension and report back to me. Okay, you've said it's good. Now I'm going to give you an event of I'm getting ready to start an extension. Now I'm going to tell you to actually go ahead and start the extension. So it provides a place to say, well, what happens if I'm calling these things directly from my own little XPC stub? What if I don't call validate extension? What if I don't call will start extension? Or what happens if I call terminate extension on random things? And ultimately, this was kind of the thing that I was looking for one level up in the system extension daemon that I ended up finding what I was hoping for, which was a way to kind of get something to happen that wasn't intended to happen. So I ended up kind of in my stub application with something like this. There's a OS system extension info class. It's another one of those internal system extension framework classes, and it's got all sorts of different properties about the system extension. Normally, system extension D is filling out all this information after it's done its validation, passing it across, and was able to kind of just boil it down to, no, as long as I specify a staged bundle URL and give it this identifier value of any random string I want, and then call start extension, Endpoint Security D will happily do just that. And what really hit me about this, in this case I used the calculator, why not copy calculator? But the best part was, what's really happening is Endpoint Security D asking LaunchD to run this as a system daemon as root. So calculator pops up, there's nothing you can really do. Now it's running. You want to quit it? Great, it's going to pop up again. I pretty much had to restart so that the endpoint security stuff would shut down because I hadn't really activated the system extension in the proper way to get it to go away. But this was pretty exciting, and I found this pretty early on in the beta cycle of Catalina, and kept thinking to myself, okay, these are new daemons, especially endpoint security. It was very clear during the beta process of Catalina that this was something in flux, in motion. Apple was still kind of creating it and was really releasing it as a way to get feedback from developers. But but it never got patched. So Catalina then got released. I reported it to Apple, and they did then include this fix in 10.15.1. Again, I kind of went back to reversing. This is basically Objective-C code that I've just reversed from the disassembly of the patch. It's another one of those classes in the system extension framework that is internal, OS system extension point listener. It was clearly meant to be a class that Apple would use in all future system extensions. So while the bug that I found was just in Endpoint Security, if they had any other system extensions, it would have had the same bug. And it literally was just no entitlement check at all. So any client could connect to Endpoint Security D and attempt to kind of send those messages and ask it to do things. It was an easy fix, but I mentioned earlier that one of the biggest, I think, architectural issues and challenges is the complexity of all this. If I put on my developer hat, looking at how Apple built this, I wouldn't want to try to test this whole process. It was hard enough to test this whole process as a developer, if anybody who used the framework knows. But it's one of those things where if I ran a dev team at Apple building system daemons, I'd probably make sure that I had entitlements as like my number one thing on my code review checklist to make sure we have. So it's just, nothing against Apple or their dev teams. It's just, I think, again, to kind of point out the complexity of it all, it's easy to kind of miss this. And this is really the pattern that I see Apple doing more and more. More entitlements, more system daemons, more granularity, which is good from a security perspective, but can be really challenging from kind of building that type of system perspective. So, just a couple closing thoughts on all this. Is it a good framework? Do I think system extensions and specifically endpoint security is a good framework? It's a resounding yes for me. I think there are just too many positive things about this framework to discount it. On top of the fact that Apple is kind of saying you don't have a choice; you're going to have to use the framework. But I do wholeheartedly believe that it should lead to better system stability, less third-party code in kernel space. I think it's easy to just shove too much stuff in kernel space that really shouldn't be there. I think it leads to kind of less attack surface as well. You have less of that third-party code in kernel space, especially with the security area. I think just from my own sort of reversing of various kernel drivers, it's pretty common to see sort of lots of cross-platform C++ code shoved into a kernel driver and then that kernel driver running on a Mac. So there's just a lot of code, a lot of chances to have bugs. So I think that's good. And I think one of the biggest things is that it really enforces a good architecture on the endpoint security products. It's a pattern that Apple has been using for a lot of years at this point, trying to keep their kernel drivers as small as possible, communicating to system daemons and putting that code into user space. And for better or worse, I'm willing to say, I trust you, Apple, to kind of do that kernel extension well, and that communication between kernel and user space well. I'll give up maybe a tiny bit of performance. It's not perfect though. I mentioned a couple minutes ago, like it was very clear that Apple, even though they were releasing it with Catalina, that it's really kind of, they're iterating quickly. So I would definitely encourage anyone using this, file bugs with Apple, send them feedback, follow radars. I do truly believe, that they want to make this successful, this framework, endpoint security especially. I think anybody who does Mac or iOS development, has probably felt the pain of not feeling like their feedback goes anywhere. This is a case where, I've seen Apple kind of following up and trying to get this framework right. So, and then just a couple links. If you go to my GitHub, there's a CVE repo. You can download the proof of concept. It is only going to do anything cool on 10.15.0, so hopefully you saved, all your installer images to get back to that version. And then I have a little skeleton app of Swift talking to Endpoint system extension, Endpoint security system extension, but written in Swift. Actually very similar to the whatever the app that just came out this week from FireEye. And then if you want more details, there's a couple posts I've had up on the blog, as well as Jonathan Levin had a really nice write-up on some of the kernel space stuff. And yeah, that's it.